Hi everyone. I hope we're okay and the studying is productive. And I hope you guys are well preparing for your prelims. Today, guys, this video will be about. I'll be just answering trigonometry questions now, just trick questions, because we are still doing the topic of trigonometry. The sad part about IB questions is that questions are just scattered. They are not structured with. They are not structured like DBE, because you know that question 4, 5, 6, and 7 could be just trigonometry, not for 5, 5, 6, and 7 rather. It's just trigonometry, so it's easy for you to navigate where the questions are. But it's fine. Nonetheless, guys, let's just work, because we have to. If you're new, guys, don't forget to subscribe. Okay, I have 1 minus 2 sine squared theta is equal to a negative 1 over 7. I'm told that whatever x value I find, it should be within that region. So that means I must not just end by determining the general solution. I must actually find the values. Okay. Whenever you simplify, guys, in trigonometry, whether they say determine the general solution, prove the identity, or just simplify, there are steps we need to follow. Né? There will be a link on the description. Please follow that link. There are videos that will help you to understand each aspect of trigonometry. Please, guys, go and watch those. Nah? Okay. This thing is an expanded version of a double angle for cos. So I can, whenever I see this thing, I can simply write cos 2x is equal to negative 1 over 7. Then the following thing I'll do to just find my reference angle. My reference angle should be cos inverse. Note that I do not include the sine whenever I find my reference angle, right? For me to find my reference angle on my calculator, I must press shift, then cos, and then I must write whatever that is there. This will give me a negative 81. Why am I saying negative? It will give me 81.79 degrees. 81.79 degrees, right? So my duty is to express, excuse me, my reference angle where cos is negative. Why? Because cos 2x is equal to a negative number. So how can I do so? I know that cos is negative in the second and third quadrant. So in the second quadrant, angles are written as 180 minus. So I'll say 2x is equal to 180 degrees minus 87 minus 81.79 plus k 360, where k is an integer, all together. So therefore 2x is equal to 180 minus 81.79. I'll get 98.21 plus k 360. Then x is equal to then x will be equal to what? I divide both sides by 2. I'll get 49.11 plus k 180. And then for the other one in the third quadrant, 2x will be equal to 180 plus 0.71 degrees, where k plus k360, right? Where k is an element of integers. So 2x is equal to 180 minus 180 plus 81.79. I'll get 261.49 degrees plus k360. Then whenever I divide both sides by 2, I'll get x is equal to 130 degrees 0.75 plus k 180. Then all I need to do is to just substitute the different integer values, okay? And then simply say x is equal to let's take the first general solution. I have 49.11 plus k 360. K represents any integer. When I substitute 0 there in space of k, I'll get 49.11, which is within the restriction. Another x value. Whenever I substitute 1, excuse me, I don't have 360, I have 180. Whenever I substitute 1, I still get a number which is greater than 90. So I need to go to the negative numbers. I get a negative 1. Whenever I substitute negative 1, I get a negative 130.89 degrees. And then let me check. Whenever I substitute negative 2, what do I get? I get a number which is less than 180, so I don't have to go further. And then now I need to focus on the second solution. The second solution, I have 130.75 degrees plus k multiplied by 180 as well. The first integer value I'll substitute is 0. I'll get 130.75, which is greater than 90, so it's not applicable. So I don't even have to go to the positives, because whenever I find 1, whenever I substitute 1, I'll simply get a number which is greater than 90 as well. Let me rather do negative 1. I'll get negative 49.25 degrees. Okay, let's check when we say negative 2. Negative 2, we get a number which is more negative. So these are my answers for the general solution. Okay, let's find another question. We must simplify the following. Nah? Whenever I simplify, guys, the first steps are to reduce the angles. I have negative cos theta multiplied by this thing, cos cubed theta, 90 plus theta, right? Whenever I see 90 plus, I must change to the co-ratio. But before I change, I want to check that's the trigonometric ratio I'm changing. Is it positive or negative? 90 plus is in the second quadrant and cos is negative. So that means I'll have a negative sine cubed theta minus tan 180 minus is in the second quadrant. Tan is negative there. I have negative tan theta multiplied by cos theta, which is already reduced, and then negative theta is in the fourth quadrant. Cos is positive there. Okay, so this means I have negative and negative. I have a positive cos theta multiplied by sine cubed theta minus, or here I have negative and negative as well. So I'll have a positive sine theta over cos theta multiplied by cos theta and cos cubed theta. What will happen is that this will go with this one, right? And then I will have cos theta plus sine theta. Okay, I can take out a common factor here. I have a common factor of cos theta and sine theta. Whenever I do that, on the first term I'll be left with sine squared theta. On the second term I'll be left with cos squared theta. Then I'll have cos theta multiplied by 1. This will be cos theta times sine theta. Now this is simplified. Okay, let's go and check another trig question. I haven't done 3D yet. I'm going to leave this thing, but don't worry, I'll answer it when I do 3D. Okay, let's prove this identity. Let's prove this identity. I have 1 plus sine 2x plus sine x minus cos x. Okay. On the left hand side, right? I have sine 2x plus sine squared x plus these two, a positive 1 and a negative cos squared theta will give me sine squared x. Are you together, guys? Okay, and then at the bottom I have 1 plus 2 sine x cos x plus I have a cos 2x there. I must change it to a double angle, right? Since I have a positive 1 there, I must change my cos 2x to the one that will eliminate this one. So I'll change it to 2 cos squared theta minus 1, not theta but x. Are you together? So that the ones will subtract one another there at the denominator. And then at the top I will have 2 sine x cos x plus 2 sine squared x. And then at the denominator I'll have 2 sine x cos x plus 2 cos squared x. The ones I've subtracted already. Né? There's a common factor at the numerator is 2 sine x. Whenever I take it out, I'll be left with cos x plus sine x. At the denominator, I have a common factor of 2 cos x. When I take it out, I'll be left with sine x plus cos x. I know that this will cancel with this one, and then this will cancel with this one. I'll be left with sine x over cos x, right? Which is equal to the tan of angle x. Then I've proven the identity. Now I'm asked to determine the values of x for which the identity is undefined. How many marks? 6. Okay. Since it is 6 marks, that means I must take this complicated side and make it to be equal to 0. So I have 1 plus 2x cos x plus cos 2x is equal to 0, right? I must just find the general solution here, guys. So I'll still have 1 2 sine x cos x plus this will be written as 2 cos squared x minus 1. Why? So that the ones will subtract one another. I'm left with 2 sine x cos x plus 2 cos squared x, right? Can take out a common factor, which is 2 cos x, and then I'll be left with sine x plus cos x is equal to 0. And then 2 cos x is 0, or so this thing is just cos of x equal to 0. The reference angle is just the cos inverse of 0, which is just 0 degrees. So therefore x is equal to 0 plus k 360, where k is an integer, or x is 360 minus 0 plus k 360, where k is an integer. And then for the other side, I'll simply have tan sine x is equal to a negative cos x, right? Whenever I divide both sides by a cos, I will have tan on one side and a negative 1 on the other side. So my reference angle is tan inverse of 1, which is equal to 45 degrees. Then my duty is to express the 45 degrees where tan is negative. Remember that for the angle of tan, you can only substitute for the angle of tan, you can only have angles in the first and second quadrant, right? So since tan was equal to a negative number there, that means I'll express my reference angle in the second quadrant. So I'll have 180 minus 45, which will give me 135 degrees, plus k 180, since we're dealing with tan, where k is an integer. So these are the general solutions that will result in our identity being undefined. Are we together? So that's how you would have tackled the trigonometry questions in the IEP question paper. Is there any? Let me check. Okay, there it is. Okay, I'm told that if 2 cos 2a is plus sine 2a is equal to r cos 2a minus beta, where r is greater than 0 and beta is an acute angle, determine r and beta. Okay, if you come across a question like this, guys, always the time, please try to expand the right hand side. Yes, we'll have r cos 2a cos beta plus sine 2a sine beta, right? So this thing is equal to we have 2 cos 2a plus sine 2a. This is r cos 2a cos beta plus r sine 2a sine beta, right? Since these two things are the same, and we can see that both of them are separated by just a plus sign. Simply means that 2 cos A is equal to r cos 2a multiplied by cos beta. Are you together? And let me just write so that everything will fit. And then the second part is also equal. Sine 2a is equal to r sine 2a sine beta, right? For the green part, if you can divide both sides by cos 2a, we can see that we'll say that 2 is equal to r over cos b, which simply means that cos b, excuse me, cos b is equal to 2 over r. Are you together? And since since cos b is equal to 2 over r, let's just leave it like this and focus on the red part. We can see what we can conclude later on. If we can divide both sides by sine 2a, I'll be left with 1 this side and r sine beta. So sine beta is 1 over r. If we can draw this triangle here, if you have an angle of beta there, cos by definition is adjacent over hypotenuse. So that means you have 2 over r, and then sine is 1 over r. Are you together? So I can simply find r by using the Pythagoras theorem. I know that r squared is equal to 2 squared plus 1 squared. Then r squared is 5. Then r is the square root of 5. Are you together? Now I know that r is equal to the square root of 5. Are you together? I can also find the angle of beta. Beta, I have this side and this side, ne? Then tan of beta is equal to opposite over adjacent. Therefore, beta is tan inverse of 1 over 2. Beta is equal to 26.57 degrees. Are you together? So now I know that this thing is equal to 26.57 degrees. Yeah, so I did find the values of r and beta. So I can simply conclude that now I can simply conclude that 2 cos 2a plus sine 2a is equal to the square root of 5, the cos of 2a plus 26.57, just like that. Okay, now I'm told that hence or otherwise determine the maximum value of that. Okay, I have 4 cos squared A plus sine 2A, right? They want me to find the maximum value here. Okay, if they say hence, it simply means I must try to use what was given to me previously. Okay, how can I make this to look like this? How can I make it to look like that? Like that. Okay. If I can say that 4 cos squared A minus 2 plus sine 2A plus 2, there's nothing I've changed here. Why? Because let me write both of them in blue just to show you. I've just added 0. There's nothing I've changed here. Are you together? But I know that this thing is equal to this one. Are you together? How so? Please note what 2 cos squared A minus 1 plus another 2 cos squared A minus 1. When I add these two, when I add this and this, I'll get this guy. Does it make sense? When I subtract -1 and this one, I'll get this guy. Are you together? So I'm trying to expand there at the top. These two things, this on its own is cos 2A. This on its own is cos 2A. So I have 2 cos 2A. Are you together? So whenever I see this thing, which I highlighted in this in here, I can write this guy because they are the same. So I can simply say this is equal to 2 cos 2A plus sine 2A plus 2. Remember that this is equal to this one, and we hence found that it's equal to that. So we can simply say we have 5, the square root of 5 cos 2A plus 26.57 degrees. There's a plus 2 SID. Are you together? They want me to find the maximum here. How can I find the maximum? Okay, I know that this guy 2A plus I'm lazy to write the angle. 2A plus beta will be always between -1 and 1. Are you together? 2A plus beta will be always between -1 and 1, right? But I have a square root of 5 multiplied there. I can multiply each and every term by the square root of 5, and then I'll have negative square root of 5 I'll also have the square root of 5 here. Are we together? But in this case, there's a 2 added. That means whenever I want to add 2 inside, I must add it on the other side as well. So I'll have 2 minus the square root of 5 Okay, so now I know that I have this. I forgot to write a 2 in between. Okay, now I know that I have this guy here, and this guy is equal to this one. So I can simply conclude what is the maximum or the minimum. So I'll simply write here 4 cos squared A plus sine 2A. This is between 2 minus 5, 2 plus 5, right? They wanted the maximum. Okay, so this one will give me the max, it is the maximum rather, and then this one is the minimum. It's good. I don't know why they give you 2 marks for such a question, but the maximum is that one, the minimum is that one. I hope guys this makes sense, né? Please guys stay tuned and wait for more videos. I know I haven't taught maximum and minimum. I will dedicate an entire video for that. I'm glad I answered this question, but don't worry about finding maximum and minimum. It's just as simple as ABC. Please guys subscribe and wait for more videos. I think the minimum and maximum video will be on lesson number 39, if not 38. Yeah, thank you guys.